Let's do it. It's recording now.
Okay, awesome. So I'm going to go back to that if instance we've been running this whole time. So we have those tests that can run from the Sanity server. Right now, what I'm doing is I'm debugging a situation with Prism, which actually seems to see an expected issue with that testnet. So when we started out, we started very small, just doing test network connectivity, this type of testing for networks. Now we're actually going to do a real deployment of a beacon chain in the testnet environment. So here's the console output, so I can drive you a little bit through what's going on, right? So first we check out a bunch of files. Second, we actually run a script that deploys the contract to Gurley, right? We get the contract deployed with this unique hash for it. Now we go to Genesis and we tell it to deploy Prism with 3 nodes, with a log folder that we can actually parse, and with a contract that we just established, and with a password for the validator key stores. So this actually now does 2 things. It creates the 3 nodes for Prism, and then for each node of Prism, it's going to start 8 validators. So each of them have their own private keys, their own DLS signature, their own little environment for themselves. So because of that, we now have to wait quite a bit. So we actually have a wait period to make sure that we don't step over the build, as it takes a little bit of time for everything to start. What happens after that is that, okay, so during the process of that build, we actually generate all the private keys. To make it possible for us to access them as Jenkins, we have to change the rights. That's kind of a patch here. But then after that, we actually do sending transactions to Gurley. So I have here the Gurley email address that we use. We have 2,000 ETH on that Gurley address, so it's going to be good for a long while. And you can actually see the real transactions that have been deployed as part of this exercise. So this is real. There's no simulation. We're actually talking to the test.
These are the validator bonding transactions, correct? In order to become a validator and deposit your 32 ETH?
That's right.
Perfect.
So we have a way to cheat with Prism. They don't have to be 32 ETH. So we use a much smaller value because otherwise I'd be spending a lot of ETH every time. The other good thing is that they have a way for you to retrieve the value back to your account as part of the contract, as part of the testing that they set up. So it's not as bad as if I was burning ETH as part of this.
Right.
So now we're doing the transactions. We're sending all that stuff. You can see the hash, right, for each of them. It's kind of cool. And so we're doing this, so 8 validators, 3 nodes, 24 times, right? It's quite a bit. Now we can sleep for 5 minutes. We can actually see Prism is running. We can test its connectivity. We can test its Prometheus reports, and this is where things don't work because they don't actually generate epochs yet. So I'm working with a team of Prism right now. They seem to have a bug where they're not finding out that the chain start event is taking place. We're able now to do a bunch of things. So I'm actually working closely with them. They asked for more of this output, so they're really interested by this output, which is great. They're not just shrugging me off. So I'm very happy about that. And I can show them all the stuff that's going on inside all the log files of this stuff. So all the log files are being captured as part of this.
So
I can
send
show
these to teams as they get generated for help with debugging.
Exactly. So now I'm having much better discussions with them where I can show them the truth as I see it at this point. Here is, for example, the log file for the beacon chain, for the beacon node number 2, right? For the beacon node number 2, we see we have a number of validators, so 2-1, 2-3, etc. So if I click on one of them, now it's saying unknown status, which tells me that there's a problem. So that tells me that something is wrong and that we need to fix it. So this is a little bit of a tour of what I have. I was showing you earlier in the Sanity build. So Prism is special in the sense that they went all in. They don't want to simulate chain start. They actually do this for real, right? So everything is really close to reality. Lodestar is another one that apparently does it this way. But Artemis is much more lenient and has a way to simulate the chain start and the Genesis event when it starts, which saves me a lot of trouble. So Artemis can actually do a real epoch generation. So here I have a good build from them. I can actually see all the epochs that are being tested. So when we test the epochs, which we test for each of them, the finalized root, the justified block root, the justified block state, the justified block root. So we have a set of tests that we can do to test the output of that. So here is the actual, all the hashes that are being tested. I changed that output so it's now putting a markdown table, which is a bit more readable, but still very much a bunch of X codes. But it's also interesting to see the test results. So when things don't pass, this is actually a little bug that I'm fixing. We see promises not reporting, so you can actually see it's failed. So we can start doing that on a nightly basis and actually test the clients as they go along, so we can really see them, as we generate new tests. In terms of the tests in themselves, what we do is we grab the logs that I showed you earlier, so actually catch on all the elements that we want to check for.
Awesome. Would you mind highlighting that that sort of build matrix that you showed for Prism? Is that same thing exists for Artemis?
So I think you're talking about this, which is
This guy, the pipeline view. Mm-hmm.
So the pipeline build is actually a way for you to define different stages in your build. Those stages are being defined in a file, which is stored in source control by us. And you can see the different tests that are being tested as we go. For now, we're making this a sequential kind of testing. But as we go along, we're going to be able to make more parallel forks and branches. And the other thing that's good is that you could also have this run on different machines as you go.
Right.
I can show you, here is the actual file that tests everything that there is to test. So for example, the consensus tests are actually done like this. We have the network test here. We have the setup stage, which I was showing you the logs of, is actually being tested here. So everything is tracked. Everything is being provided to this. A new addition to that file that you should know about is I now have credentials. So the private key of the Gurley account is actually stored in Jenkins securely. We don't actually output it anywhere, and it's injected into the build script as we run.
Awesome, dude. I like this. I like this a lot. So I'm going to stop recording. I think this